Hi everyone. So today we are going to learn esters. Okay, in the last video we have covered carboxylic acids and their structure and reaction of carboxylic acids as typical acids. This is the last functional group that we have in this chapter, organic chemistry of IGCSE. Okay, so the functional group of ester is COO. Okay, and it is having alkyl groups on both the sides. So you can say that ester functional group is somewhere present in the middle of the whole chain of esters. Okay, name ending name ending is O8 OATE. So if you see the video of carboxylic acid where we have done reactions of carboxylic acid where carboxylic acid is acting as a typical acid, you would see that the salt which is formed, okay, is having this name. For example, if ethanoic acid is reacting with magnesium, it would give you magnesium ethanoate. Okay, so if you see that video, you will understand that we have named the compound as O8, and there also I have told you that it is esters. So here we are going to learn how we are supposed to name and draw the structures of esters. So as I have introduced esters in the last video when we were learning carboxylic acids, that esters are actually made by reaction of alcohols and carboxylic acids. We do not have a general formula that we can follow for esters. Okay, the R that I have written here, okay, R is nothing but a abbreviation used for alkyl group. So R is actually used for alkyl group, and that alkyl group can be anything. It can be methyl, ethyl, propyl, butyl, pentyl, etc. Okay, so esters are having a very sweet and pleasant smell, you would say. And because of that sweet smell that they have, okay, they are being used as flavoring agents. They are used in perfumes and have different other applications, but majority of them are used in as flavoring agents to give that fruity taste, we can say, and have that fruity fragrance. And in perfumes also, perfumery industry, they are used. Okay, so that is about use of esters. Now we'll move ahead for the structure of esters. Okay, so as I told you that esters are made by reaction of alcohol plus carboxylic acid, and this reaction is known as esterification. This reaction is known as esterification reaction. So there is a reaction condition for making of esters, which is in presence of concentrated H2SO4. Okay, so alcohols and carboxylic acid reacts in presence of concentrated sulfuric acid to make esters. This is the only reaction condition for esterification. Okay, so yeah, so for making ester, I will start with a simple example. Let's take example of methanol. I will be writing structural formulas only. So we have methanol, which is CH3OH, that is methanol. And let's take example of ethanoic acid, okay, which is CH3COOH, that is ethanoic acid. Now you have to understand one thing, that we will have to remove hydrogen from alcohol and OH from carboxylic acid. Okay, hydrogen from alcohol and OH from carboxylic acid. Now, whatever is the remaining structure that we have, okay, whatever is the structure that we have, that is important for us now. So, we are supposed to just join the structure together. Okay, so I'll write it here. Now the H and OH that is being removed is going to give us water, H2O. Okay, and I'll just copy this down here, which is CH3O. Okay, and this also I will copy down here, but I'm going to flip the structure and copy it down. Okay, so I will write it backwards, which is O, C and CH3. Okay, so this is our ester functional group, which is COO. Okay, and here you can consider this is my alkyl group and this is my another alkyl group, which is R dash. In many cases it can be same or it can be different also. It depends upon the compounds that we have taken for reaction. Okay, the alcohol and carboxylic acid which we have choose. So how are we supposed to name this compound? The name the name is first having alcohol followed by carboxylic acid. Okay, so if we go alphabetically, alcohol A comes first and carboxylic acid comes second, like next. So the alcohol which I have used here is methanol, will get converted to methyl. Okay, and from ethanoic acid you are supposed to cut this and consider only ethane. So it is ethane, and the name ending of esters is O8. So it will become OATE. So the name is methyl ethanoate. This part is my alcohol and this part is my carboxylic acid. Okay, so this is how we get the structure of ester. We will take one more example. Okay, let's take example of methanol only again, which is CH3OH, which is methanol. And this time I will take example of propanoic acid plus propanoic acid. So I will write it this way, so it becomes easy for you to understand. Okay, so we have CH3, CH2, C double bond O, OH. Okay, this will be little bit easier to understand. So as I told you, we have to remove H from alcohol and OH from carboxylic acids. Okay, and whatever is remaining, this remaining part we are supposed to copy down as it is. Okay, so this I will copy down, which is CH3O, and this I will copy down as it is. Okay, this time you don't have to flip it because I have already written the structure in that way. So I'll just put a bond between this and I'll just copy down it as it is. C double bond O, CH2, CH3. This gives you the structure, the functional group of ester. Ester functional group. Okay, now how we are supposed to name this compound? Okay, so as I told you, we have to take alcohol first, then carboxylic acid. So the alcohol which I have used was methanol. Okay, so I will be taking methyl, and I have used propanoic acid. So oic acid I will remove and write propan as it is, and ester ending is O8, OATE. So the name becomes methyl propanoate. Okay, the name of this structure becomes methyl propanoate. Let's take one more example. So this time I will take ethanol as an alcohol. So alcohol I will take here is CH3, CH2, OH, that is ethanol, plus propanoic acid only I will take, which is CH3, CH2, C double bond O, OH, okay, which is propanoic acid. If you have understood how to draw the structures, how to combine both alcohol and propanoic acid structures, you can draw it normally also. Okay, no need to draw the way I have drawn carboxylic acid. that is in a backward way. Okay, so we have to remove OH from here. We have to remove OH from carboxylic acid and H from alcohol. Okay, whatever is remaining, this part of alcohols and this part of carboxylic acid needs to be combined with each other. So this I will copy as it is, which is CH3, CH2O, and this also I will copy as it is, continue as it is. Okay, so I'll just put a bond here and C double bond O, CH2, CH3. Okay, this is my whole structure of ester. Now, how am I supposed to name this structure? So I have taken ethanol. So ethanol will get converted to ethyl. As I told you that alcohol is named first. So it is ethyl, and the propanoic acid, mein se oic acid I will cancel. I will copy down propan, and name ending of ester is O8. So OATE. So it becomes ethyl propanoate. Okay, this is how we draw structures of ester. And the naming part, alcohol first followed by carboxylic acid. Yeah, now after this we have structural isomerism of esters and carboxylic acid. Okay, so esters can have structural isomers in their own homologous family, we would say, but carboxylic acids do not. Okay, so we are going to have a functional group isomerism. Okay, so we will have a structural isomer of carboxylic acid in esters functional group. So I will take an example so you will understand. I hope that you have understood the structures, how to draw structures of esters. Now we will move ahead with structural isomer of esters first. Let's take structural isomer of ester. Okay, let's take the same example, ethyl propanoate. Okay, ethyl propanoate. Now, ethyl meaning 2 carbon atom, prop meaning 3 carbon atom. 2 plus 3 is equal to 5 carbon atom. Okay, so total comes to 5. Now, we have to find such combinations of alcohol and carboxylic acid that the total of the compounds come to 5 carbon atoms. Okay, so one way here, my ethyl was ethanol and prop was carboxylic acid, that is propanoic acid. Okay, this was ethanol which I have used, and this was propanoic acid. Okay, what I can do is I can flip both of them. Okay, I can just swap both of them. So instead of ethanol, I would take propanol. Okay, instead of ethanol I can take propanol, and instead of propanoic acid I can take ethanoic acid. When I react both of this, what will I get? The propanol will become propyl and the ethanol will become ethanoate. Okay, now here this propyl meaning 3 carbon atom, eth meaning 2 carbon atom. This will give me a 5 carbon atom compound. ठीक है, so ethyl propanoate, propyl ethanoate or are isomers of each other. Okay, the other way around, what it can be, 4 carbon compound plus 1 carbon compound also makes 5 carbon atoms. Okay, so this 4 carbon atom, say for example, I take butanol and 1 carbon atom is methanoic acid. Methanoic acid. Okay, so 4 plus 1 is equal to 5. So it becomes butanol becomes butyl and methanoic will become methanoate. Okay, or the other way around, I can just swap both of them. Okay, so here it will be 1 carbon and this will be 4 carbon, that also becomes 5 carbon atoms. So instead of butanol it will be methanol, and instead of methanoic acid it will be butanoic acid. So this methanol will become methyl and butanoic acid will become butanoate. Okay, butanoate. So butyl methanoate or methyl butanoate. So in total, we would say for a total of 5 carbon atoms, we are having 4 different isomers. Okay, the combinations can be propyl ethanoate or butyl methanoate or methyl butanoate. So whenever we draw the isomer for ester, whenever in exam if they ask you the isomer of ester, first of all, just look at the compound and figure out how many carbon atoms are present in that compound the way I have done for ethyl propanoate. Okay, you can see ethyl is 2 carbon atom and prop meaning 3 carbon atom. It gave me a total of 5 carbon atoms. And now I have to just check that what are the possibilities, how can I make 5 carbon atoms. Okay, so you just have to take combinations, that is of alcohol and carboxylic acid. Okay, a 3 carbon atom and 3 plus 2 is 5, 4 plus 1 is 5, 1 plus 4 is 5. Okay, so you just have to keep on changing the alcohol and carboxylic acid accordingly and you will get the isomer of esters itself. Okay, this is how you can do. We can take one more example here. Say for example, I have to make an isomer, for example, of 7 carbon atom. Okay, now how can 7 be made? I know that I require alcohol and carboxylic acid to make the ester. Okay, so 7, the ester should contain 7 carbon atoms. In this case, I feel 3 carbon atoms plus 4 carbon atom will give me 7 carbon atom. Okay, so I can take propanol and butanoic acid. Okay, so let's draw the structure. So we have propanol, which is CH3, CH2, CH2, OH plus butanoic acid, CH3, CH2, CH2, C double bond O, OH. Okay, now I have to remove hydrogen from alcohol and OH from carboxylic acid and copy down the same structure as it is. Copy down the same structure as it is. Okay, so it is CH3, CH2, CH2O. Now copy down this structure. Now here I will have to flip the structure. Okay, so this I will have to draw a bond here and C double bond O, then comes CH2, CH2, CH3. So if I number this, it becomes 1, 2, 3, 4, 5, 6, 7 carbon atoms. Okay, this is the structure of ester. Okay, now if I want to make, so how am I supposed to write the name? So the propanol becomes propyl and butanoic acid में से oic acid I have to cut, so it becomes butan butanoate, which is name ending for ester. So the structure becomes propyl butanoate. Okay, yeah. Now, for as I told you, the seven carbon atoms, I have different combinations. One was 3 plus 4. Okay, now in here I can just swap both carboxylic acid and alcohols. Instead of 3 carbon atom, I can take a 4 carbon atom alcohol and 3 carbon atom carboxylic acid. Okay, so I can take 4 carbon atom plus 3 carbon atom, which is equal to again 7 carbon atom. So 4 carbon atom of alcohol, 3 carbon atom of carboxylic acid. So I would take butanol and propanoic acid. Okay, I will not draw the structure here, just write the name. Okay, so butanol will become butyl, Propanoic acid में से I will just take propan and name ending of ester is O8, butyl propanoate. Okay, I will have further combinations also. Even 5 plus 2 also gives me 7. Okay, then I would say 1 plus 6 also gives me 7. So here for 5 plus 2, that is, it will be pentanol and 2 carbon atom carboxylic acid it will be. So that is ethanoic acid. Now pentanol will become pentyl and ethanoic acid will become ethanoate. So pentyl ethanoate, or we would say ethyl pentanoate. Okay, if I take 2 carbon atom and 5 carbon atoms, 2 carbon atom alcohol and 5 carbon atom carboxylic acid. Okay, so all these possibilities, that is 3 plus 4, 4 plus 3, 5 plus 2, 1 plus 6, 2 plus 5, etc., they all are isomers of each other. Okay, so this is isomers of ester. You can try for any other carbon atom. Okay. Now we will do isomers of carboxylic acid with esters. Okay. So it is isomer of carboxylic acid and ester. This is known as functional group isomerism. Okay, this is known as functional group isomerism. That is finding isomers in different functional groups out of your homologous series. Okay, so let's take example of a carboxylic acid. Say we will take example of propanoic acid. Okay, propanoic acid, which contains prop meaning 3 carbon atoms. Okay, so let's draw the structure of propanoic acid. I will just draw the structural formula here. So first we are supposed to draw the functional group of carboxylic acid. Then I require 1 and 2. 2 more carbon atoms, and I will just write H. Okay. Sorry, so instead of structural, I have actually drawn displayed formula. Okay. Now here I will be writing the molecular formula of this. So this is my first carbon, second carbon, third carbon. So I'm having in total 3 carbon atoms. Then I have 1, 2, 3, 4, 5, 6. 6 hydrogens and 1 and 2 oxygens, O2. Okay, this is my molecular formula of carboxylic acid. Now I have to find ester, which is also having 3 carbon atoms. Okay, now how should I make 3? So, 1, I know that esters are made by reacting alcohol and carboxylic acid. So I will have to choose a alcohol and a carboxylic acid that makes a total of 3 carbon atoms. Okay, so here, for example, I can take ethanol, or let's take methanol and eth, that is 2 carbon atoms. So ethanoic acid. Okay, let's draw the structure. I have CH3OH plus CH3C double bond OOH. Now from here again I have to remove hydrogen from alcohol, OH from my carboxylic acid. Then draw the remaining part as it is. Okay, so here I will copy this down, which is CH3O, and again copy this down. Just flip the structure. I have to bond the oxygen with the C double bond O of carboxylic acid. So C double bond O CH3. Okay, now let us write the molecular formula of this compound. So I have one, two, three carbon atoms, C3. 3 plus 3 is 6 hydrogens, and 1 and 2 oxygen atoms, O2. So it is C3H6O2. Okay, which is similar to C3H6O2 of propanoic acid. So I'll just write the name of this compound here. The methanol becomes methyl, and the ethanoic acid that I have, it will just have ethane. I'll not consider oic acid, okay? And name ending of ester is OADE. So methyl ethanoate and propanoic acid are structural isomer of each other. Okay, so this is a perfect example where we can say the molecular formula is same CH3, sorry, C3H6O2, C3H6O2, okay? But the formula, the structural formula for both of them is totally different. And this type of isomerism, where we have two different functional groups acting as an isomer of each other, is known as functional group isomerism. Okay, let's take one more example here. So, say for example, if I have butanoic acid, which is having 4 carbon atoms. Okay, so here let's draw the structure of butanoic acid. So we have C double bond O OH. This is my first carbon. Other than that, I require 3 more carbon atoms. So 1, 2, and 3. And I will just put hydrogens everywhere. Okay. Now, let's write the molecular formula. So I have 4 carbon atoms. Okay, 1, 2, 3, and 4. So it is C4. Then how many hydrogens do I have? 1, 2, 3, 4, 5, 6, 7, 8. H8, and I have 1 and 2 oxygen atoms. So my molecular formula is C4H8O2. Now I have to find an ester that is made up of 4 carbon atoms. Okay, now how should I make a ester that contains 4 carbon atoms? So again, you have to remember that I require alcohol and a carboxylic acid. Okay, which is very simple. How to make 4? 2 plus 2. Okay, so here I can simply take ethanol, react it with ethanoic acid. Okay, react it with ethanoic acid. So what will be the name here? Ethyl. Ethanol will get converted to ethyl, and here it is ethanoate. That is one way. Or another way of making 4 is 1 plus 3 is equal to 4. Okay, so here 1 carbon atoms of alcohol is methanol, and 3 carbon atom carboxylic acid is propanoic acid. Okay, so here what will be the name for both of them? It is methanol will become methyl, and propanoic acid will become propan. Oic acid we have to cancel out, and it will become OATE, methyl propanoate. Okay, so either ethyl ethanoate or methyl propanoate, any one of these can become a structural isomer with butanoic acid. Okay, for this, again we will draw one of the structures, so we can write down the molecular formula. Okay, so let's draw ethyl ethanoate. Yeah, so we have ethanol, which is CH3 CH2 OH, plus we have to draw ethanoic acid. which is CH3, C double bond O, OH. From here, we will be removing hydrogen from alcohol, OH from carboxylic acid. Okay, and the remaining structure I am supposed to copy down. So it is CH3, CH2O. This again I will have to flip and write because I have to connect the carboxylic acid with oxygen of alcohol, and it is CH3. Okay, so let's write the molecular formula here, which is 1, 2, 3, and 4. I have 4 carbon atoms. 3 plus 2 is 5, plus 3 is 8 hydrogens, and 1 and 2. 2 oxygen atoms. C4H8O2. Okay, so we have this compound with a molecular formula of C4H8O2. Okay, so you can see here we have butanoic acid with 4 carbon atoms, which is having a isomerism with ethyl ethanoate, or a isomerism with methyl propanoate, that have the same molecular formula, but the structure for both of them is different. One is a carboxylic acid and another is an ester. So this is all about the structural isomerism of esters and carboxylic acid with esters. Okay, I hope you have understood this. Thank you.